Lecture 24, today's notes. Today is March 28th. So let's see the first question. If the sum of two numbers is 20, what's the largest possible product? So largest possible product of those two numbers. So let's call the two numbers x and y. Or by the way, you can call any, you can use any variable, right? So two numbers, sum is 20. That means x plus y equals to 20. Now, we're considering the product of those two numbers. So let's write an equation for that. So let's say product is P equals to x times y, right? Product, we multiply those two. So we're given these two equations. Now we want to form a function out of those two equations. But ideally, if we can form a quadratic function. And if a quadratic function, remember quadratic function, we have upward parabola and downward parabola, right? Downward parabola means we have this maximum. Okay, so let's see. So maybe we want to form a function, a product function in terms of x, which means we need to get rid of this y. And yes, the first equation gives us x plus y equals 20. We can rewrite it as y equals to 20 minus x, right? You can think actually y is a function in terms of x. Y is a linear function. So now we're going to substitute y with 20 minus x. So distribute x, so x times 20, got 20x. X times negative x, got negative x squared. So let's write it in order. So we write the square term first, then the x term second. So negative x squared, positive 20x. So now clearly this is a quadratic function. And the leading coefficient is -1, right? So leading coefficient is negative. Indeed, the graph is like this. It's a downward parabola, and we have this maximum. So we want to find this vertex, this maximum. So we'll call this vertex, and in downward parabola, we call maximum. So we want to find out the x value and the function value, p of x. Okay. So how do we find a vertex of a parabola in quadratic function? We have this formula, x, so let's write down vertex. X equals negative b over 2a, right? Where is a? A is a number before x squared. In this case, a is -1. Negative b is a number before x. In this case, is 20. So we get a -20 divided by -2. Negative divided by negative is positive. 20 divided by 2, so we get a 10. So x equals 10. Now we need to find, so one number is 10. And the other number, so y equals 20 minus 10, also 10. So x is 10 and y is 10. And the biggest possible area is p of x. We just plug in. So we have x, which is 10 times 20 minus x minus 10. What is x times y, right? Which is 100. So to answer the question, the largest possible product is 100. And the two numbers, if they ask for two numbers, the two numbers are 10 and 10. So what have we done? We using the given data to form a function. All right. Then it's a quadratic function. We will use the property of a quadratic function. to find its vertex. It's a downward parabola, so we'll find that this vertex is a maximum. A maximum means the y value, the function value is maximum. Okay, now let's see question 2. So question 2, we have 200 feet of fencing to enclose a rectangular area, borders a river. If we don't need to fence the side borders the river, the question is, what should the dimensions of the rectangle be to enclose the largest area possible? Let's draw a picture. We have this rectangle area. One side borders the river, doesn't need fencing. So we need to fence this side, and fence this side. It's a rectangular area, so the opposite sides are the same. That's why I mark this side W width, this side also W width. Right? So we have these 3 sides. So which is W plus L plus W equals to 200. Right? Equal to 200. And then we're trying to find out the largest area possible. So let's write down equation. The area of this rectangle is just L times W, right? Length times width. So we're working with these 2 equations. Again, we want to form a function. So from the first equation, we get 2W plus L equals to 200, right? Or we can write L as 200 minus 2W. Now we can substitute this L, right? We can form a function, the area function in terms of width, because we got rid of L. Because L is 200 minus 2W. Then multiply by W. So distribute W, get 200W minus 2W squared. Write this in order, we have negative 2W squared plus 200W. Again, we want to use, we're finding the vertex. Again, we see a downward parabola, graph, right? Downward parabola has this maximum. So we want to find the independent variable. So that's negative B over 2A. B is a number before the variable, which is 200. A is a number before the variable square, which is negative 2. So we get negative 200 divided by 2 times negative 2. Again, negative and negative become positive. 200 simplified with this 2, get 100. 100 divided by 2, get 50. So the width is 50. Then the length is 200 minus 2 times 50. 2 times 50 is 100. 200 minus 100 is 100. So the length is 100. Well, what is the possible area? This question actually only asks us for dimensions. Dimensions means the length and the width. But let's find the possible biggest area anyway. So A of 50. Right. So when the width is 50, that gives the rectangle gives the biggest possible area. So A of 50 equals to length times width. Length is 100. Width is 50. So 5,000. Okay. So 1 and 2 are very similar. We use the equations. So we use the data given to form equations. Then out of equations, we want to form a function. Let's see 3. 3 talk about the absolute value function, the graph of absolute value function. So this is absolute value function, right? It's a V shape. It's a V shape. And we use this as reference graph to graph other absolute value functions. Okay, we use this as reference graph. We call this function like a basic function. So compare this one. So let's call this a g of x. Right? G of x is absolute value of x plus 3. And this is f of x plus 3. Okay, so that's the relation between f and g. Where g just pushes up function f, the graph of function f, 3 units up. So usually we work with a couple points. So let's work with 3 points. Right, let's pick these 3 points to work with. So this point is the origin, 0, 0. This point is 1, 1. This point is -1, 1, right? Because absolute value of -1 is 1. And the absolute value of 1 is 1. Absolute value of 0 is 0. So pick these 3 points to work. Now this one, so G, let's make a table here. Let's see, this is the x value. This is absolute value of x plus 3. So x, let's choose the 3x, -1, 0, and 1. And absolute value of x, absolute value of -1 is 1. 1 plus 3 give us 4. Then absolute value of 0 is 0 plus 3, that's 3. Absolute value of 1 is 1. 1 plus 3, also 4. So get these 3 points, -1, 4. -1, 4, get this point. 0, 3, get this point. 1, 4, 1, 4. Right, we can graph because you see absolute value function is a V shape. So 2 straight lines, 2 symmetric lines. So this is on the left-hand side, on the right-hand side. That's it. Compare those 2 graphs. You see every point being pushed up 3 units. So this is called a vertical shifting. Vertical shifting. Let's see 4. We have this square root of x. And this, we have this graph of square root of x. So we also work with the 3 points. So we have 0, 0, the origin, and this one 1, 1. This one 4, 2. Right? Square root 0 is 0, square root 1 is 1, square root 4 is 2. So let's work with these 3 points. So this will be horizontal shifting. Horizontal shifted to the left, to the right. When x minus a number, there's a shift to the right 4 units. But let's use a table value anyway to confirm that. Because I see this is x value shifting. So basically 0, 0 shifted to 4, 0. 1, 1 shifted, so let's mark this 4, 0. And 1, 1 shifted to 5, 1. And 4, 2 shifted to 8, 2. So this is 8. So the graph is this. Not straight, okay, it has to be curvy, it has to be smooth. Like a roundish. Okay, roundish. Okay, so that's the graph for g of x. Let's write down g of x. And this is f of x minus 4. All right. Because what does f do? F square root the input. So here, square root of x minus 4. So the input of f is x minus 4. So this is a horizontal shift. Well, let's check with the table values. Let's see, x square root of x square root of x minus 4. You see here, we cannot pick, let's skip this square root of x. We cannot pick 0, 1, 2, 3. Why? Look at the domain of this one. The domain is x has to be greater than or equal to 4. So we have to start with 4. So let's start with 4. So if x is 4, we get 0, because 4 minus 4 is 0. Square root of 0 is 0. Then let's pick a 5. 5 minus 4 is 1. Square root of 1 is 1. Then let's pick 8. 8 minus 4 is 4. Square root of 4 is 2. So that's how I got these 3 points. 4, 0, 5, 1, and 8, 2. So this point is 8, 2. Okay, horizontal shift. Let's see, 5. 5 also treat the absolute value function as a reference graph. Now let's call this g of x. G of x is negative f of x. So this is a reflection. So let's use these 3 points again. So 0, 0, the origin, negative 1, 1, and 1, 1. 3 points. But here you see negative f of x. So that means the y value, the function value, be negative. So before with the negative 1, before with the 0, 0, or negative 0, still 0, 0. So we still get this point. But before with the negative 1 and 1, now the second number, the function value 1, is a negative 1. So we have a negative 1, negative 1. We have this point. 1, 1 before, now the function value, the second number be negative, be negate. So we have 1, negative 1. We have this point. Right? So that's the graph. Oops. You see the negative f of x, right? Negative. If you want to check, you also can use this table value. Let's say this is x. This is absolute value of x. This is negative absolute value of x. Well, x is a negative 1. Absolute value is 1. X is 0, 0. X is 1. Absolute value is still 1. So that's these 3 points of this, right? But this is a negate the absolute value. So negate 1 is negative 1. Negative 0 is still 0. Negate 1 is negative 1. So that's why we have negative 1, negative 1, negative 1, negative 1, 0, 0, 1, negative 1, 1, negative 1. So you see this is a reflection. So reflect absolute value of x over x-axis. Right. Now let's see 6. Six will have this quadratic function. Right? Let's call it g of x. G of x comparing to f of x is 2 times f of x. That's a relation between those two functions. That's why we can call g is a transformation of f. So 2 here stretches the graph. Let's still work with 3 points. 0, 0, 1, negative 1, 1, and 1, 1. And the graph is different from absolute value functions, right? Because this is roundish, it's a smooth. So when we graph, we have to remember the shape of the graph. So you see this one doubles the function value, right? So 0, 0, double 0, still 0. I still have this point. Double 1, I get negative 1, 2. I get this point. Double 1, I get 2. So I get this point. So this one is negative 1, 2. This one is 1, 2. Right, then I graph. I don't graph straight, I graph, I graph roundish. Sorry, it was very difficult for me to graph on this drawing pad. I graph roundish. Doesn't listen to me, the pen. Right. So basically I graph something like this. Like the graph on the left, but it's skinnier because it's being stretched. The graph is being stretched. Okay, work with 3 points. 0, 0, still 0, 0 point. That's in transformation, that's called dilation. So 3 kinds of transformations, right? Translation, which is horizontal shifting or vertical shifting. Then reflection is a negation, put a negative sign. Then stretching or dilation is a put a number, multiply by a number by scalar. Now let's go back to absolute value function. So let's call this G, right? So how is G related to F? We can write this as equals to 2 F of X plus 3. Let's still work with 3 points. 0, 0, 1, 1, negative 1, 1. These 3 points, okay? So now first we stretch. We do this one. We do 2 times absolute value. So this one we're going to graph 2 times the absolute value of function x. So still 0 times 2 still 0. Then 1 times 2 get this negative 1, 2 point. Now we get this one 1, 2 point. So we draw this. We draw straight lines. Straight lines. A V shape. Okay, you see the graph of V from the reference graph is being stretched. Now we add 3 to it. Right? We add 3 to all the Y values. We add 3 to 2, we add 3 to 0, we get 0, 3. We add 0 to 2, we get 5. We get negative 1, 5, and 1, 5. So I have these 3 points. So I have 0, 3. I have this 1, 5, negative 1, 5. Draw straight lines. Straight lines. So this is the graph of 2 absolute value of x plus 3. Okay, you can make a table values to check. All right, you evaluate at negative 1, at 0, at 1. You will get 5, 3, 5, right? Okay, that's a combination of the transformations. So all absolute value functions is a transformation of its basic function. F of x equals absolute value of x. Now let's see piecewise function. Why is it called piecewise? Because we have 2 pieces. You see, before the function, we only have 1 piece. If it's quadratic, right, it's 1 piece of string. Or linear, 1 piece of string. square root one piece of string. This is piecewise, so I have two pieces here. Got two pieces here. One piece is defined from negative infinity up to 0, including 0, is defined as 2x, a linear function. But if x is bigger than 0, it's defined as a quadratic. So now let's first evaluate some values. So f of -5, this means x equals -5. So -5 is in which interval? First or second? Seconds are positive, right? In the first one. So -5 is in this interval. Then in this interval, we have to use 2x, the function 2x. So 2 times -5 is -10. F of 0, or 0 also in the first interval. It's an endpoint. 2 times 0 is still 0. F of 3. 3 is in the second interval. In the second interval, we have to evaluate with x squared. So that's a 3 squared, which is 9. Okay. Now let's graph this function. Let's graph piecewise function. So we need a couple points, right? Let's say first interval, maybe we use 0, -1, -2, and 0 here. And positive x, maybe we use 1, we use 2, 1, 2, 3. The y value 3 squared is 9. Okay? We better make this smaller. So let's see this. This is a 3, 6, 9. So the increment on x and on y doesn't have to be the same. All right, I can use anything convenient for me. -3, -6, -9. So now let's use these 2 points. We already have these 2 points. Right? So -9, so -5. So this gives us a point -5, -10. 1, 2, 3, 4, 5. So let's see, -5 is here. -10 is a little bit lower than -9. So I have a point somewhere here. So this is a -5, -10 point. Then let's grab this one, 0, 0. That's just the origin. So we have, how is the function defined? 2x. We just connect. So 2x is a linear function. It's a straight line. So we just connect those 2 points. And of course, this keeps going. So we indicate with an arrow. So it's a straight line from 0 down to -infinity. X greater than 0, we have x squared. So get a 1, 1, 2, 2, 2, 4, 1, 1 somewhere here. 2, 4 somewhere here. 3, 9 somewhere here. Okay. So this graph. It's greater than 0, so we have to start with 0. Well, if 0 is 0, we make an open circle, but we already have a solid circle there. So we get a parabola. Okay. You see the 2 pieces, but somehow 2 pieces are connected. Sometimes the 2 pieces are not connected. So the left-hand side of y-axis will have straight line. The right-hand side will have quadratic, a roundish, smooth graph. Let's see this one. 9, 3 pieces. So I have 3 pieces. So the first interval is from -infinity up to -2, but not including -2. The second one, including -2 up to 1, including both. The third one from 1 up to positive infinity. We see each interval is defined differently, right? Constant function defined from -2 down to -infinity. Quadratic function defined in between -2 and 1. Then a linear function defined for all x values greater than 1. So let's evaluate those couple. F of -4, -4 is in the first interval. So that means first intervals will look at the function, how is the function defined, a constant function, -3. F of -2, -2 in the second piece, right? Second piece, that's x squared. That's -2 squared, which is 4. F of 2 is here, in this interval. So that's 2 times 2 plus 3 to evaluate this function, which is 7. So when we graph this, we also graph with 3 pieces. First, x less than -2. So let's see, this is -1, -2. From -2 down to -infinity, that's -3. Let's see, this is 1, 2, 3. This is -3. +1, +2, +3. Right? But -2 is not in the domain of the first piece, right? -2 is in the second domain, but not in the first domain. So what do we do? But we have to start with -2. So we draw an open circle. So, okay, so this is f of x equals -3. A constant function. Now, from -2 to 1, including -2 and including 1, let's see, this is 1. We have a quadratic function. -2 squared is 4. So let's see, this is a 4. To have this point. Then -1 squared is 1. At this point, right? 0, have 0, 0. 1 squared is just still 1. So we graph smoothly, okay? We graph roundish. Oops. Roundish. And that's it. Just from -2 up to 1. To have this piece. You see, those two pieces are disconnect. The third piece is 2x plus 3. Well, 2 is in the domain. So we have 2, 7. So this one gives us a 2, 7 point. But we have to start to evaluate at 1. Then we make an open circle. So if x equals 1, we have 2 times 1, 2 plus 3, 5. So let's see, this is 5. So we have this point, but to this point, since 1 is not in the domain, so we make an open circle. Now we have 2, 7 point. So let's see, this is 2, 7 somewhere here. And it's a straight line. So we just connect those 2 points. You see 3 pieces. The left piece is a constant function from -2 down to -infinity, but not including -2, so we make an open circle. Between -2 and 1, -2 and 1 are all included in the interval, so we make a solid dot. Right, then we'll graph a quadratic. The third piece is 2x plus 3, the linear also. We evaluate at 1, even 1 is not in the domain. So we have 5, 1, 5. Then we make an open circle. Then we get another point, 2, 7. Then we can draw the graph. So we see 3 pieces. So this typical piecewise function. And that's it. That's the worksheet.